Exponential functions. That's section 11 too. We're going to talk about graphing them and using them and the properties and whatnot. Okay. First of all, just to kind of clarify, there is a difference between a power function and an exponential function. Now, if you notice on a power function, the x is the base, and then the power is just a constant. So here's your variable, and it is the base of the power. On an exponential function, the exponent is your variable. Okay? So y equals a times b to the x. That is a general form of an exponential function. And b is the base of the exponent. B is the only thing that's going to be taken to that power. A gets multiplied after. Don't forget your order of operations. If b is greater than 1, we have an exponential growth. If b is between 0 and 1, not including 0 or 1, it is an exponential decay. Some properties of exponential functions, characteristics of the graph, starting with domain and range. Okay, domain and range. Here is an exponential growth, exponential decay. Domain and range are the same. Domain is going to be all real numbers for both, and your range for both will be y is greater than 0, period. Okay? The range will vary if, say, a is negative. If a is negative, then that flips it over. So it's going to flip over this sign. If there is a vertical shift, that's going to change your range as well, up or down, by whatever that number would be. Okay. The y-intercept, it's always going to be the number 0a. Okay, unless there is a horizontal shift, which I don't think we're going to be looking at those. Okay, so it's always going to be 0a, and sometimes a is not an actual number that's written down there. Let's say we have y equals 2 to the x power. A is 1 in that case. Okay. The behavior of the graph, it's continuous, meaning there's no breaks in it. It is one-to-one, meaning it's a function. And in this time, it's increasing. So exponential growth is increasing, exponential decay is decreasing. And that means it's increasing as you look at the graph from left to right. So this is going to be increasing, decreasing, it's going to start real high, and it's going to end real low. And you'll see when we graph them that these motions I'm making with my arms are the directions that the graph is going in. Horizontal asymptote, okay, they say it's the negative x-axis, meaning that's where it gets closer to it. Here's the positive x-axis. And there's no vertical asymptote because your domain's all real numbers. Alright, graphing. Here are 3 equations. We've got y1, y2, and y3. I'm going to graph them all on the same set of axes. I've actually got the points already done here for us. X is negative 1, negative 2, negative 1, 0, 1, 2. Okay. Some of them, sometimes you might not be able to graph negative 2 and positive 2 just because the numbers either get so tiny or so large. Just depends. But with 2 to the x, okay, if we were looking at y equals a times b to the x, a is 1 in this case, in all of these cases. A is 1. And then the plus 3 and the minus 2, those are going to be vertical shifts. So that's going to change your range when we get there. Okay, so we just start by finding the points. Okay, plugging in negative 2, that's going to be the 1/4. That's going to be 1/4. Negative 1 is 1/2. 0 is 1. Da 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 da. So on and so forth. You plug in x and you do the math. With these other ones, these are just vertical shift. So really, all I did, let's see, we plus 3. So it's 2 to the x. I added 3. Added 3. Added 3. Added 3. Added 3. That one's minus 2. Oh, a quarter, minus 2, minus 2, minus 2, minus 2. Okay? So now all we've really got to do is plot the points. We've got -2 at a quarter, half, 1, 2, and then 4. There's that one. Okay, the next one I guess I'll graph it in blue because I want to do the different colors. Okay, so 3 1/4, 3 1/2, 4, 5, 7. Eventually it will run into the other one over there. Okay. And I've got red I can use for the other one. Okay, so there's those. Now the domain's going to be all real numbers for all 3 of them. Okay, I can put anything I want in for x. So the domain's going to be all real numbers for all 3 of them. On y1 is the parent graph, so the range is going to be y is greater than 0. Okay. For y2, the range is going to be greater than 3. So y is greater than 3. And then on y3, the range is going to be y is greater than -2. -2. All the points are greater than that. Okay. And similarly with exponential decay, here's exponential growth. We start off real low, and we're going to just increase very quickly as we move from left to right. Okay, exponential decay. Here we've got y1. y1 is 1/3 to the x power. Okay, again, if it's ab to the x, a is 1 in this case. Plus 3 minus 2. That's a vertical shift of 3 and a vertical shift of -2. We can do our domain and range first. Your domain is going to be all real numbers. You can plug in anything you want for x. We're not limited. Your range, this one's going to be y is greater than 0. The range here, y is greater than 3. The range over there, y is greater than -2. So when we graph them, okay, -2, 1/3 to the -2nd power is 9, so it starts out high. -1 is 3, 0 of course is 1, and now we're to 1/3 and 1/9. It starts out really, really high and it decreases very, very quickly. Y2, here we're just adding 3 to each one, so, and 6, 4, 3 1/3, 3 1/9. Okay, the horizontal asymptote changes. These have a horizontal asymptote. And for the third one, -2, 7. -1, 1. 0, -1. And then our fractional ones that we just got to estimate. And you can see very easily how close together they get here, because they are going to run into each other. Okay, inequalities. Great. Graphing an inequality. This is where you've got to pay attention to solid or dashed line and shading. Okay, it's not an equal sign here. So you got to pay attention to solid or dashed and shading. You still graph it just like you would graph anything. Okay, again, it's 2 to the x plus 1. So it's been moved up a little bit. So at negative 2, we're at 1 1/4. So 1 1/4. Then at 1 1/2. And then at 2. And then at 3. And then all the way up to 5. And then since this is just a less than, this is the dashed line. Okay, then you pick a point, okay? What's my favorite point to use? 0, 0. 0, 0 is not on the graph, so I'm going to plug in 0, 0 for x and y. So 0, is it less than 2 to the 0 power plus 1? 0 less than 1 plus 1? Check. Yes, it is. So we're going to shade this region below the graph. Okay, so you graph it like it's an exponential. You just graph the exponential and then you choose where to shade. Be careful with your dashed and solid and choosing where to shade. Only if you don't have an equal sign, that's when you worry about shading. One very useful example of an exponential growth is compound interest. Okay, the compound interest formula, A equals P times 1 plus R over N to the NT power. This is an exponential growth. Okay, it doesn't grow that quickly unless you have a higher interest rate, but it is an exponential growth. Okay, P is the principal. That's the amount you start with. R is your interest rate. N is your number of times compounded per year. And T is the time in years. Okay, so let's say I have a money market account that I invested $3,000 in. I wish, but whatever. I got 4.2% interest rate compounded daily for 10 years. Okay, you use the formula. That's all you have to do. I want to find out how much is in that account after 10 years. So A equals P, my principal. That's my starting. That's the amount that I invested, 3,000 times 1 plus R. Now, am I going to put 4.2 or should I use the decimal form? Decimal form, always. 0.42 over N. Number of times compounded per year. It says compounded daily. So how many days in the year are there? There are 365. And we just kind of forget about leap years in there. We use 365. And then NT, so it's 365 times T. T is 10 years. So 365 times 10. And then you can just use your calculator to do this problem. That's okay. So 3,000 times 1 plus 0.042 divided by 365, close parentheses, raised to the power, and I'm putting, 365 times 10 is 3,650. That's my exponent. At the end of 10 years, this money market account will have increased to $4,565.77, rounding properly. Okay, I started with 3,000 and in 10 years I earned $1,565.77 in interest. Okay, you know what interest is? It's free money.